Good afternoon. Thank you for joining us. My name is Cam Johnson, and along with Liz and Matt, we're going to go ahead and talk a little about our transformation from operations to supporting research at UNLV with Splunk. Liz is going to get this kicked off for us. So, Liz?
Yep. How many folks are from higher ed? Just a few? Okay, so this is a higher ed use case, but you could think of it in terms of customers or any sort of use case outside of higher ed where you're trying to retain customers or something like that. It can also be applicable as well. So let's get going here. Right, so disclaimer there. We'll skip right through that. So one of the things that we find in higher ed that keep presidents up at night of an institution is, there's lots of things that keep them up at night, but if you ask, a handful of institutions, what's the key thing? The thing that you'll hear most often is student success and retention. And there's many reasons for that, and they come down to a few key things. They want to know that every morning a president wants to know, how many students are we retaining, how many are we recruiting, and that comes down to a concern about a lost immediate and future revenue for the institution. Right? That's their bread and butter. That's where they get all of their money for operations and things like that. If you take a look at some simple metrics here, assume you have 4,000 first-year students at an institution and the tuition's at $32,000 a year. If you lose those students, that's lost student tuition, it's lost fees, it's lost housing costs, and it's also a lost future giving. Right? So institutions try to get alumni to contribute back to their endowment. So it's a big issue for higher ed. Other key factor is performance-based funding. A lot of schools are under a model where they have to perform, they have to show metrics. A lot of state institutions don't get funding from the state if they're not retaining and graduating students as expected. And then, obviously, the U.S. News and World Report's rankings and things like that, if your rankings are going down because you're not retaining students, it's a big factor. So after all those things that keep them up at night, what is it that they really want in the morning besides a good cup of coffee, to get rid of that headache of the declining student success numbers? Well, they want to retain and obviously educate more students, right? That's their key thing. And they want to minimize those lost revenues and make sure that they're still able to bring in the right students and build that lifetime learning experience and that lifetime relationship with the student so they're contributing beyond their years at the institution. And then they turn to the staff there at the institution say, well, do more with less, right? We don't have the funding, but we need you to make sure that those numbers are still going up, and we're not going to give you any more money to do that. And they want them to be proactive. They don't want to know, at the end of the semester that, oh, we lost 5 or 10 students or whatever. They want to know now. What is it that we can do to impact the student success and retention rates at the time that they're engaging in their activity, right? And, so you might think, operational data, log files, that's great. They'll help institutions look at their security or, DMCA notifications, search for, what students are downloading illegal content and things like that. But how is it going to help with that student success and retention? Well, that data is really rich in activity data, in what students are doing, whether it's in the classroom, on campus, what they're buying, where they're going on campus, so if they're going to the dining halls, all of that engagement and activity data. And doing more with less, this is a story about how UNLV actually did that. Right? They had data that they were already Splunking for IT operations. And they realized that there's value beyond that. So if you start bringing in data to enrich it, you can see it in many different ways that'll provide value. So as we go through this, they're going to walk you through, talk about how they started off using that data in Splunk, and brought that to Matt was doing some research, and he said, well, how can you help me with this data? Can you provide me some information? So they went through, the operational insight to the data science and analysis, and actually being able to predict or try to predict student success and behavior. So, all right, so we'll start off with the IT operations part of it.
Thank you. So I manage a group at UNLV, which would traditionally be considered like a NOC, right? We're called an operations center, but we offer a wide range of services, monitoring, typical SNMP stuff, network infrastructure, firewalls, data center, stuff like that. Log aggregation and search, which is what we call Splunk. And then I also have to manage the data center, and we do tier 2 support. This is important because my group has great visibility about what's going on campus, and we actually have a pretty good understanding about most of the stuff that we're consuming with Splunk. For us, our journey with Splunk started back in 2010. Typical use case, we had a bunch of logs on servers. Server admins wanted to know what was going on, and we needed a way to kind of operationalize those logs. So in 2010, we solved that problem. We went out, we looked at all the competition that was out there at the time, which there was not much, decided on Splunk, and we got to kind of trying to solve some problems. From there, it really became a little bit of a sales job for me in trying to get adoption of Splunk on campus. And I have things up here like stop saying Splunk, because for a year, all I did was say Splunk in meetings. And so it was, well, can we do this? Yeah, we can use Splunk. And so I kind of became the Splunk guy. A little bit after that, we started to get some customers and doing some neat things. And I got in the habit when someone would say, well, what can Splunk do for me? I said everything. Right? And so that was, all right, I got to stop saying everything, because everything doesn't mean anything to maybe a non-IT person or even to an IT person. And so had to start kind of adapting again. So I stopped saying Splunk, I kind of stopped saying everything, and started to transition on. It was about that time that we had a really good use case for our learning management system logs. We had limited help desk hours outside of the traditional 8 to 5, because we had a hard time getting some of our student employees access to data. You can imagine there's some constraints around what we're allowed to provide to student employees, and Splunk was a really great use case for this. So we went to the server admin, who was kind of the gatekeeper of this, and presented by doing this, we can extend our hours of support to include weekends and after hours. A little bit of negotiating, we put Splunk forwarders on 16 of their servers, and we started consuming those logs. And it was good because we started to actually understand the data a little bit. And now we had our help desk being able to do a lot more. And it was about that time in 2013 where 2014, where Matt came to us and said, hey, I've got this idea for a research project, can you help me? And after that first meeting, I think it was either 3 or 4 pieces of data that Matt needed. It turns out we already had it, right? And this was kind of the great thing about going from operations to supporting research, which is that we had that data already. It took a little bit of validation to make sure that we understood what the data actually meant, and we worked with Blackboard on that and some of our local experts. And then for the last couple of years, we've just been grinding away on this, right? And the good thing is, by kind of working with Matt and getting Splunk out there in some different ways, it allowed me to get funds to secure additional licensing. And then from there, it allowed me to do a really big infrastructure upgrade. So it was a good kind of evolution for us with Splunk. Skip that. I think Matt has the... Yep. You have the next one? And so what we're going to do now is Matt's going to talk a little bit about the research that he's doing and how he's actually using the data that we're providing inside Splunk, and then I'll come back and wrap it up.
Okay, great, thanks. So sticking with Cam's timeline, 2013-ish, we pitched a project to the National Science Foundation for their program on research on education and learning. And that's where the little search and discover mission, where the two of us sat in a room and I logged into the LMS and Cam tracked me in Splunk in real time so we could figure out what was what. And we were able to confirm early on, kind of pre-data construction, that this was viable. And then we went through a process once we were awarded funding, from data construction through to figure out, well, how do we model this data to take it beyond just basic ops data, to understand something about students rather than something about the activities that exist on the server. From there, we were able to kind of submit those data to some analyses and then actually create a meaningful intervention for students. So that's what I'll walk you through. So if we think about the data construction piece, and we think about the context that we're trying to reconstruct using the data, we tend to think of college courses as places where students are the active learners, but their instructors also give them the raw material to do the active learning. So what we'll be talking about today is a large lecture course. It's anatomy and physiology. one instructor, 3 sections of 200 or so students per section. So not much opportunity to have some real interaction with their students, except for the ones who are interested enough or desperate enough to come actually go to office hours and things like that. So we've got a large lecture course. It is textbook based, and a lot of learning happens outside the LMS, but we've worked with the instructor to try and create a really large corpus of resources for learning within the LMS so we can try and understand the student learning experience. So if we think about that, we've got resources available to students where instructors intend students to use calendars to plan, syllabus to plan, and maybe a list of learning objectives so they can kind of track their progress over the course of the semester, monitoring whether or not they're actually achieving those learning goals on time. We've also got just the raw resources that instructors tend to push out. So lecture notes, either partial for completion during lecture or complete versions. They get assignments that they complete in the environment. And then they get opportunities to kind of self-assess. So you get assignment solutions, so you can check what you got wrong and ideally restudy those things. You've got opportunities to monitor your learning. So we build out self-assessment quizzes. They're not graded, but we can see students who are practicing and monitoring their understanding. They can check the grades, and we can build scaffolds that kind of help students think through, if I'm going to be studying for this exam, what are the phases, how should I plan, what strategies should I use, is this working, should I adapt? So these are the kinds of student-facing pieces in the project, where each of these can be understood by the category of the kind of learning process that the instructor intends for the student to do with it, and they can also be understood by their content ID within Splunk. So this will look familiar to pretty much everybody in the room. Just using basic search and looking at some of the really common fields that show up when you're logging LMS logs. We can see timestamps, the course IDs as hosted in the learning management system and identified. Same story with content IDs in the search here. But I'll draw your attention to the things that we're layering on. So this is really our data logging and enrichment phase, where we have just a basic ingestion of the Splunk log, or of the LMS log in Splunk. And on top of that, we're layering metadata. We're doing it just with Google Sheets and using just a simple lookup process where we have a couple of Google Sheets that some undergraduate and graduate students in my lab manage. So we use just a querying tool to say, what is this stuff in this course? Listing it by the content ID, and then we label it by what the name of the thing is that the student sees, and then we categorize it, which is kind of a critical piece of it. So we categorize it specific to a class, and then we categorize it to the kind of learning activity that the instructor intends that piece to induce. So if we look at this log, these are events that happen when students access resources within their math course. We can see it's course 181, so it's Calculus 1, section 1001. So those are all on the key of the course ID. And then we can see on the far right side, those are some of the learning-related metadata, where we take these from kind of just logged events to learning events. So we can see that this happens to be a student who is working with our learning assistant. So with these data, we have a log of about 1 million or so rows over the course of a semester, with users somewhere on the odds of like 800 to 1,000. And we use Pivot in Splunk to try and understand what do those learning events look like on a week-by-week basis, and what kinds of learning events are they. So we use Pivot to just kind of break things out and bin timestamps into integer days and then into semester weeks, so we can look at early behaviors as they might predict later performance. So here we can see in week 1 student activity across assignments, using any communication tools, navigational stuff like accessing content folders or links within the course site. And for any given student, we could see that, like, say this student in week 1 visited 5 different content areas, navigating the link structure on the left side of the page, and then was able to dive into just one folder, and there was able to download 2 sets of lecture notes. So we capture all those in log form, but then we pivot them to try and make a bit of an aggregation so that we can use this for prediction purposes. So we can model this using just some basic descriptives, so we can see, like, the higher bars tend to be navigational behavior, like links and folders. We see a good bit of interaction with some of the online resources, like the self-testing resources that we built with the instructors to test knowledge of different biology chapters, and a decent amount of access of planning resources. Less so of the other stuff, and some of that is because it's downloadable. So we need to make some data decisions about how to interpret this stuff too. So some things, if they're downloadable, then we have to treat it as dichotomous data and model that. On the bottom right here, we can also see what behavior looks like over time. So we've got the different categories of different resources for different kinds of learning processes. And I think the biggest takeaway here, how many people can guess what the mountainy pieces here are? So over the course of 15 weeks here, we have 3 very clear instances where tests were given. So we see a big ramp up in activity immediately before and a huge refraction right afterwards. So students are doing absolutely nothing after the test is over, other than just some basic navigational stuff. And then it really spikes during the final. So this is kind of comical to most of the instructors who are looking at this. So we take all this data, and once we've enriched it, we can now actually do some things with it. So our project looks like this. So we really want to predict students' achievement in the course and give them feedback earlier than they would when they get their midterm grade, and it's a poor one. So we use Blackboard data, so our LMS logs. We push those into Splunk so that we can model it over time. And then we go through this process where we've logged it, now we've modeled it, brought it all into the same data model. Now we can model it in some kind of data mining software, apply that model to future students based on past students' data, and try and predict their performance. And once we've done that, we can identify which students are likely to perform poorly and figure out how to intervene. So we go from Blackboard into Splunk. We've thus far used a tool called RapidMiner, which is just a readily available and commonly used data mining tool. And in that, we've applied a forward selection logistic regression algorithm where we look at all the individual content names, and now we're using resource type as well to try and build a model that predicts students' outcomes. So here you can see different kinds of things that students could do overall or on a week-by-week basis. And each time they do that, we increment up their score of their likelihood to get a positive outcome, meaning here a B or better in the course, because that's what these biology students need to move forward towards their degree. If they don't do these things within a period, they gain no points for having not done them. And some of them are actually negative predictors. So if you happen to do this activity, which might be useful, like planning might be useful in week 1, not so useful if you're doing it too late. So we actually decrement your score. So those all get pushed back into Splunk, and then we can model future students in real time. So whenever they do or don't do these different activities, we just add them up via a series of reports and have a single predictor, where if it's positive, they're more likely to get an A or a B. If it's negative, they're more likely to get a C or worse in the course. As of week 4, we cut that. And then it's time to figure out, well, how do we want to get in touch with these students? So we've applied the model back into Splunk, and we can try and get in touch with students about 2 weeks before their first exam in the course. And that can have trickle-down effects towards the later exams in the course as well. So at this point, our models are about 85% accurate for identifying the C or worse students. So with just 4 weeks of data, we can get some kind of alert out to a student, and we can be right that that student needed it about 5 out of 6 times. We can capture 5 out of 6 of those students. This is a little bit liberal in terms of how we're treating the students predicted to get an A or a B. So sometimes we will message some of them to our hit rate is less good on that group. And as we kind of work forward, as we keep improving our models, we're now considering, now that there's a machine learning toolkit available within Splunk, whether we can keep some of these operations in-house and kind of close the loop for our production cycle here to try and build our models. So we have this opportunity to alert students. And at present, our method for doing this is to issue an early warning, which we just call a check-in on your learning. So we send out a message from the instructor to the student first day of week 5 of the semester, 7 to 10 to 14 days before when their first exam falls. And it's written to be reasonably innocuous and being an expression of concern from their instructor, with a couple of key features that we've been manipulating to see whether or not turning it on or turning it off makes the message more powerful for students. So we start out just with the salutation, and one of the manipulations is whether or not we include their first name in it. Quick heads up that the exam is coming. And then we decide whether or not we should give them negative feedback that says, hey, our data suggests that you are likely to fail, or maybe we don't mention that. And what we do then is just direct them to 2 sets of resources. The first is just a really quick advice page where you can get some advice from students who have gotten an A or B in this class. They recommend how they did it and what worked for them. And then they get a little confirmation from folks in the College of Education that say this makes sense for how learning is supposed to happen, so good luck on your exam and maybe try this stuff out. And then we also suggest that if they don't know how to do this, they can use some web training that we've designed as part of this same NSF grant. Where students who spend about 2 hours learning about learning strategies, how to self-manage in a university environment, tend to outperform their peers who don't do this training by 3 to 5 points per exam in this course. So by pushing both of these resources at students and having them come from the instructor, we kind of create this scaled ability for the instructor to reach out to as many as 600 of her 600 students if they all were eligible for a message. So these are just a screenshot of some of the learning resources with UNLV students and then their their suggestions to students who follow them. So the actual student benefits, probably the whole reason to conduct the project and to show up today. So 50% of the students who take this course have to retake it. So if you need to get a B or better in this course to move on, the failure rate's somewhere around 40%, and a number of students end up missing by just a little bit. So of the 600 students, we projected using our model that 305 of them were eligible for a message. And we sent out a variety of different levels of messaging. And within those who received messages, about a third of those students beat their projection. So those who would have been predicted to be in the see or worse group, about a third of them earned an A or B on that exam. So that's a really encouraging start. So we're continuing to do some model improvement to try and make our accuracy better. And we're also trying out different ways of messaging to try and figure out how to effectively reach out to the students. So that's really where the science of messaging is very much unknown at this point. So we don't know if alerts always help. We don't know if they have negative impacts on motivation or different effects down the line. We do know thus far that they seem to be at least prompting more activity and some better performance for some students. But we're trying to kind of tweak the features of those. So when we personalize the message, that seems to do better than when we don't. It's a little bit less clear whether the negative feedback helps or hurts. And we are seeing that the message does seem to have a lasting effect. So performance on exams 2 and 3 and 4 does seem to be better for those who do get a message and access the resources as compared to those who don't. So we messaged a couple hundred students in this first attempt. Last week I messaged another 750 more before I got on the plane to come here. So we're reaching into the thousands and building out models for biology, calculus, college algebra, engineering, and looking to expand to different departments beyond STEM majors as well. So we're kind of excited about the quick progress thus far and reasonably hopeful that we'll kind of be able to figure this out and maybe even create a transferable use case that can be applied in other settings.
Yes, sir. So I'm going to talk a little bit about what it takes to actually support what Matt's doing. And something that's worth mentioning is a couple years ago they changed the funding formula in Nevada with how universities actually get kind of the money for their students. And we moved from an enrollment model to a graduation model. Right? And so something like this becomes really important because if we're only getting money based off of what we're graduating, it's more important to get students through these programs and actually get them with degrees. So our environment, our Splunk environment at UNLV is I would consider it kind of very normal. We've got a 100 gig license, we use about 60 gigs a day, and that's a good mashup of a bunch of stuff. From there, you know, kind of the normal stuff. Well, once you get down into the Blackboard, which is our learning management system, you can see it represents about half of the data we consume. And then again, there's 16 servers that we have forwarders on, and we go from there. The breakdown of Blackboard data, about 18 gig is access data, which is actually what he uses. So every time a user clicks on something, it's just a simple clickstream data. That's what he's using, right? So I click on something, it records the IP address, my username, the content ID, date, time, and that's what Matt's basing his research off of. Right now it's 12 courses, and the content IDs there, those are the actual unique things that we translate using Google Sheets. What gets interesting though is whenever you start thinking about scaling this, right? And so right now it's Matt with some graduate students, it's my team supporting him, but we're doing it with Google Sheets because that was a really easy way for us to get them to interact with the data inside Splunk, enrich it, and do it on their schedule and not have to come to us every time. And we really didn't feel like implementing a database solution at the time was something we wanted to pursue either, right? We wanted to keep this as lightweight as possible. But for just one section, you can see that there's a lot that kind of goes into that if you tried to scale this, it would be tough. And so Matt, being forward-looking, says, well, I want to offer this to more instructors, and you know, campus hears about it, and they're thinking, oh, well, maybe this would be good. But the task that we're really struggling with right now is how would we do that? How would we scale this? How would we have to change what we're doing? Does Splunk even make sense at that point if we were to scale it to be where we kind of keep all this, right? Can maybe some of this come through Splunk and out to something else? And so, again, the challenge there is just scale. The great thing, though, about working with someone that's doing research, and I alluded to this a little earlier, is just that you know, this has really kind of forced us to understand the LMS a little bit more than what we did when we were just providing it for IT support. And it created some really good indexing opportunities. And I think this is the takeaway for me that's kind of the best part of this, which is I never really had something that I can hang Splunk on and say, no, look, this is what we're doing, and this is really cool, and you know, maybe we should start doing some other stuff. but this has given me the opportunity to go out and to talk to other departments and say, maybe we can start indexing some of your data to help, and maybe even we can apply it to Matt's research. And so this has been a great project that I can get out there in front of campus, and it means something to most of campus, right? When you talk about retention, progression, and completion of students, that's what we're about as a university, and so it becomes a little bit more valuable. And really, in a lot of ways, like I said, hanging my hat on it, this is something that validates the decision in 2010 to go with Splunk, which for us was pretty important. By learning more about the learning management system and being able to pull in other data, we're able to start to do a lot more for our client services group, right? So this is that kind of race car strategy, right? If you have a race team, that the technology is going to trickle down to the Toyota you drive every day. And this actually happened with us, and we were able to start by having to help Matt with onboarding and to learn more about the data and figure out new and creative ways to do stuff. We're able to trickle that down to other things. And so, this is kind of your stock user lookup dashboard that we provide for our client services group, but it brings in a lot of different data. The notes posted for users from a Google Sheet. So if there's a student that maybe is having a recurring problem or needs to get flagged whenever they call the help desk, anybody can go at the desk and put that user's name in there, and then if anybody searches for it, it pops up and says, hey, this user's having this problem. Footprints is our ticketing system, same thing. Now we're able to query our ticketing system, and we were doing that before, and now we have a better way of doing it based off of what we learned from working with Matt. The web campus login activity, this is probably the biggest benefit, is being able to let our help desk folks know what's happening with the student as they're interacting with the learning management system in relatively real time. And through the power of Splunk, we're able to do a lot of really neat things like what browser they're using, right? And well, that takes away that question when the user calls, what browser are you using, what version is it, right? We already know, and so we've been able to empower the help desk with that. And then also what network they're using and stuff like that. Is it internal wired, or were they on wireless? And so that's pretty good. And then, again, the benefit of being able to work and get other data, we're able to provide their enrollment information, right? And so, again, adding more data to the help desk to be able to help them students in kind of a quicker time. And then straight LMS data is something like this, so this is just kind of a modified version of what Matt uses. But this allows them to see what students are actually clicking on inside the learning management system. This actually comes in handy whenever there's a question about whether a student did something or not, right? So that was the original use case with the help desk. Is a student would call and say, I was taking this test and it logged me out, or something happened. And so the student would go to the instructor would come to our administrator, our application administrator, they would work with the server admin to get the logs, they would have to interpret it. We've cut all of that down to just this now, and so you can actually look and go, well, no, we didn't see you log in, you actually didn't click on that. We can provide that to the instructor, and then the instructor can work with the student to figure out what happened. The other thing it doesn't show it here, but we consume our load balancer logs too, and so if there's a problem with the system on the back end, they get a sorry page. It says, sorry, the service is unavailable. That'll actually show up in here as well, so if the student says to the instructor, oh, I got the sorry page, they can actually go and look and make sure they actually got the sorry page, versus just hearing from their friends if you say, I got the sorry page, that you don't have to do the work. Some lessons we've learned from this is that relationships really matter. Matt was a great colleague in this whenever we got started, and I would say that we've put a lot of time and effort into our teams working together, and I know for me that I am a little hands-off on this because my team has such a great relationship with Matt. I know Matt trusts a lot of his graduate students to do a lot of the work. There's some oversight there, but that relationship really matters, and having an advocate like Matt on campus, where wherever I'm out there pitching something, I can use his name. And they're like, oh, I know Matt, I know what he's doing. It has been a really great benefit. The other thing, too, is identifying the roles, how important that is. Very early on, we made it clear that we were the data custodians, and that was it. Right? So from an operations standpoint, I was all concerned about making sure that the data was good. And that's a little bit different than dealing with operations sometimes. If there's a little bit of log data loss in normal operations, maybe you care or you don't care. With Matt and the research he's doing, we really cared, right? So we put a lot of time and effort into making sure that all the data is there that he needs to do his research. And I think the one kind of real big takeaway from this is what we're doing with Splunk is very kind of vanilla, but I think that's a benefit, right? Knowing that I can deliver a solution and it doesn't take a lot of customization, it doesn't take a lot of really hard work to do something, is good. If you go back to before data models and Pivot, this would have been tough, right? It really would have, to enable Matt to do what he needed to do with the flexibility. But data models and Pivot allowed us to do that. The REST API calls to Google Sheets to get the data. That's all kind of vanilla stuff, but it works, and it works really well. And we don't worry about this complex behemoth we built. Is it going to fall apart whenever it gets stressed? Because it is just pretty stock. So for us, the next couple steps, trying to get more data, and we've been working with our decision support group to get what I call biodem data, but institutional data about students. Maybe what high school they went to, what their GPA was in high school, are they a first-time college attendee, things like that. And I think Matt's going to look to incorporate that into some form into his research. So not just what is the student doing, but who are they, right? And we've actually gotten great support with this. The decision support team is really excited. And a while back ago, I was concerned that they would think that we were encroaching on their territory, right? Like, I was operations, they were institutional data, and I think they saw really quick that that's just not the case, right? Like, we can work together, provide data to each other, and they're actually more excited about getting our operational data to help inform kind of the institutional decisions that'll get made. And so that's really exciting for us. Growing the team, scaling the solution, those are things that we're trying to really kind of tackle. And it's been good talking with people here, because I think it's made us think about the scaling solution a little bit more and what needs to go into that. And then the final thing is UNLV is hosting the last presidential debate on October 19th. And so we are splunking as much of that as we can. So you can imagine what goes into putting on a debate, but it's great having something like Splunk in our back pocket to where when someone says, I need this, or how can we consume that? It just goes into Splunk. We're able to create one view of kind of what's going on at the debate. And it's also been really good for me to get out there in front of some folks that I've not traditionally met with. We're going to Splunk all the Twitter data for our social media team, right? Both for real time, but then being able to historically go back and answer questions as well. So that's a great opportunity for me to get Splunk out there and try and get it used in non-IT ways, which is where I really see kind of the biggest growth on campus, right? We can Splunk IT stuff all day, but there's a lot more use cases out there for kind of non-IT stuff. So thank you very much for attending. If there's any questions, we'd be more than happy to answer them.
There's a mic. Yeah, maybe we can have somebody bring it around even. Either way.
Thank you. This was a great session. I really appreciate you sharing very unique research and use case for Splunk. I'm curious, it sounds like the data that you're using for the predictive model is primarily coming from the activity that the students are doing in the LMS. Is that right?
Yeah, so all of our data right now in our model is coming from student activity, and then we usually just layer on our metadata to try and understand what that activity is and treat it either as an individual access of one item or of an instance of a category of items.
I thought it was a very interesting idea, though, that was mentioned sort of at the start of the presentation about potentially leveraging other data about student activity on campus, maybe from badge-in information or what they're doing on campus. Are you considering trying to pull in some of those variables for your future models?
Yeah, and really it's a matter of what kind of data exists on campus and folks' amenability to bringing it into our data model. So I think the biggest push for me has been to try and understand the priors about a student. So it's much easier to know how to predict what a behavior means for a student if you know what they're coming into a course with. So if we can get at their prior credits, get at their high school experience, get at demographics and things like that, we can tune our model much more specifically to personalize to that student and know whether or not there is one model for every variety of student, or if there are subsets of students, we can make more specific models with that. So that's one big push we've had, and that's pretty much done now in terms of getting that data connected, and we'll just be refreshing it semester over semester. But then to get at what doesn't happen in the LMS, but is also activity data, is the bigger challenge. So we have engineering instructors who are gung-ho about having their students swipe as they come into the classroom so that we can just have lecture attendance as part of our model, which should probably predict a good bit of variance in the outcome. So it's kind of pocketed as to like who the data providers are and what quality the system is, so that we can kind of tie it into the data model, or if there are challenges to that.
Yeah, I can speak to that as well. So UNLV is actually getting a school of medicine, and we were talking to them, and they're a little interested in what Matt's doing, and this is about 5 years away before they're really kind of spun up, but they want to do the same thing. They're interested, like, well, can we use clickers, which is just a system they use to kind of take attendance. Can we incorporate that into what Matt's doing, right? And it's like, oh, that's a great idea, right? And so it gets back to the attendance, but clickers are actually used in classes to gauge student participation as well. So there's a lot of opportunities there, and I think building on what Matt's doing, I think we're going to see a lot more down the road.
Yeah, and I guess one other piece that's similar to that is like textbook companies are starting to get a little bit better at logging their own data as well. So I have a friend at Pearson who I'm working with who's trying to bring in not just the LMS experience, but also students out of the classroom off our servers, but with the textbook experience to try and build a more complete picture of that experience as well. So that'll be a new venture since it'll be outside data providers and figuring out how the API connections work there. But I think as we demonstrate more predictive power with what we have, I think it'll be easier to make the case that just getting that little bit more from this new data feed will be a useful approach.
I have probably 100 other questions, but just bear with me for two more. So have you considered, you mentioned you're using RapidMiner for developing the predictive model. Mm-hmm. Did you investigate, or are you considering looking at the machine learning toolkit within Splunk?
It's part of my homework while I'm here to figure out whether or not we can move our operations there, and had a really good conversation last night about some of the challenges when you're kind of validating your model. And it sounds like much of that can be accommodated, and we're on to kind of the fine-tuning and the 100 other questions as to how are we going to port over, or can we? Because the processing power is greater. It's just a matter of whether or not it's the most appropriate way to get it done.
So. And then lastly, have you published this research at all?
Not yet. It's in process. We have one poster at Educational Data Mining that has like a preliminary version of this, and I can talk with you offline if you'd like a connection to that.
Okay, great. Thank you.
Sure.
Any other questions? Well, again, thank you very much for coming out. We really appreciate it. Thank you.
Thanks.